So, oh, and I have this little 3D printed mic clip that I printed last night. And I have my extension cords, so I don't feel like I'm quite as tethered. See, look at this. So looking at the homework, yeah, I just wanted to sort of preview before I clicked it. And also I know that if I click it before 8 o'clock, it'll shut me off at 8 o'clock. But anyway, was there anything that we need to look at that was particularly problematic? I can't remember. It seems like I answered a question or two yesterday. Uh, but, uh, but if any of these need further elucidation, I'm happy to do that to help you out just with the algebra. The one on the, just as a quick preview, the one on the quiz is sort of similar to the first one, just a quadratic, so it's pretty straightforward, pretty simple. It's surprisingly similar to that one. So nothing too crazy, nothing like this, for example. That's a little bit more algebra involved in that one. And this wasn't too bad, I don't think. Neither was this. The black one, by the way, if you hadn't figured it out. Oh, wow. Oh, was there no other? Oh, here we go. So there was this one where you had to do the first and second derivative. We didn't talk about second derivatives or third derivatives. It's the same idea as a first derivative. You just do the derivative of the derivative. And there's going to be a good reason from a calculus perspective to do that. For now, it's just like playing a game. Thomas, what do you think? Really? First part wrong and second part right? Wow, let's do it. Just a minute. That's irritating. H approach. I wonder if there's a problem with the, like these are all sort of coded. There's some sort of a like automatic formula. Maybe something's wrong with the formula. Let me see how I do. Give me a sec here. X plus h cubed. I'll show you what I'm writing once I get it written. Minus 5 times x plus h minus 5 minus negative 3x cubed minus 5x minus 5 all over h. Okay, let me show you what I've written. So I hope I copied this correctly. Here's what I've started with. And then I have to do this nasty cubing. Give me a sec here. I'm going to do this quickly, though, because I'm assuming that you know how to do your algebra. So x squared h, 3xh squared plus h cubed minus 5x minus 5h minus 5 plus 3x cubed plus 5x plus 5. Yeah, this could be a problem with Lumen, not a problem with you. That'd be nice to know. Okay, so let's see. This is going to, I'll just start canceling that. That's going to cancel there. This will cancel. This will cancel. So that leaves us with negative 9x squared h minus 9xh squared minus 3h cubed minus 5h. Did I get it all? I think I got it all. Okay. Yeah, if you got the second one right and the first one wrong, then I'm really suspicious of Lumen being the problem here. Okay, so let's factor out the h, cancel. You end up with, so I'm skipping a couple steps here. 9x squared minus 9xh minus 3h squared minus 5. And then that becomes, oh, just do the limit. Negative 9x squared minus 5. So that's what I'm getting. Let's see if Lumen likes me. So let's see, this is going to be negative 9x squared. Oh, you know what? Why am I even bothering? Oh, no, I should do it. I was going to click the little key there to see what the answer was, but let's actually do it because you had to suffer with this. So if it's not right, then it's not right. I'm just going to do this one using the shortcut that we're going to learn today. There, now let's see. So instead of using a limit, well, I got them both right. Huh, weird. So you got them wrong? Did you have the constant? Because the constant, that negative 5, maybe? Do you have the same question as, like, do you have the same problem as me? Okay, so you should have negative 9x squared plus 6 should be your f prime. Yeah, plus 6. Ah, okay. So that may be the problem. It's just a simple plus or minus. I wonder, can I see? Here, let me just a sec. I want to see if I can see what you're doing. Hold on a minute. Let me go over here. Because I know with my other homework online, like I worked with a guy from statistics this morning, and he was having trouble getting through a particular problem set. And I looked, and he had done like 300 questions from that and gotten like most of them wrong. And it just kept, because anyway, statistics, the homework system is a little different than this. So I could see exactly what he was doing. And then so we worked through the things this morning. Let me just see. So if you don't mind me experimenting for just a sec, I'll show you what I've got here in just a minute. Let me just pull up Lumen. And can I pull up a person? Let me see if I can pull up a person. Can I pull up Thomas? Just a minute. Let me see what Thomas is doing. I guess I can't. It just shows me your information. Hold on a sec. Gradebook? Let me try Gradebook. Okay, let me go to Thomas in the Gradebook. Sorry, I'm just picking on you, Thomas, because you're so awesome. Okay, so here we go. This one is derivatives. Where is it? Derivatives. Which one is this? Sorry, I've got this long list. And just a minute, what is this one called? Oh, the derivative is a function. Okay, give me a sec. Does it say practice? Yeah, they're all practice. The derivative is a function. Defining the derivative? No. I found it. Okay, now let me see. Click on the score. Oh yeah, it shows me what you answered. And it shows me your problem, the problem that you worked on. Just a minute. So, yes. Interesting. Yeah, it is negative 9x squared plus 6. So if you don't, do you mind me putting it up there for everyone to see? Yeah, no, you don't mind. It's not a big deal because now we all know. So there it is. So this is what I see. So I guess that I was just curious to see how it worked. So if you have an issue, I can actually go in and look and see what you've done to compare. But yeah, so those are different. The plus 6 is the right answer. So I don't know what you bring your answers, but now you could do it right with the late pass and get 50% off that one problem. You still get it'll end up being 0.25 out of 0.5 for that part of that problem. You know? Okay, you don't care. Anyway, okay, so let me pull this back. So, but no, this is exciting that now I can see how it works. Thank you for letting me figure that one out. Okay, is there anything else that we need to look at from this? Yeah, that was way more difficult than, wait, did I do this with this? Did I do this with this on the screen? Or was I just doing this up here without you seeing it? No, we can see it. Oh, good. Phew, because I sometimes just am working and then someone is like, we can't see what you're doing because I didn't switch it up here. Okay, good. So the main thing for you is that for the quiz, you're going to do that. You're going to use that expression. Here, I'll even write it up here. So just to remind you, it's the limit as h approaches 0 of f of x plus h minus f of x over h. And you're going to have to do a bunch of algebra to do that limit. So we can do this. It's only a quadratic, so it shouldn't be too hard. So let's give it a go. That way we can move on, because today we get to move on to the easy way of doing these things. So you're going to be either happy or angry after today. Maybe a little bit of both. Happy that you don't have to do limits. Angry that I didn't just show you the trick yesterday or the day before. for this one. See, you're one of those people. Yeah, I sure can. Yeah, it's irritating you. Give me a sec. I gotta grab my glasses. Yeah, this is always a challenge to find the mistake with an algebra problem. Because I got the bottom one. Mm-hmm. I see the mistake. So when you cancel this, oh wait, I don't see the mistake. Okay, this is the mistake. This should be 3h to the third. Oh. So then that would be 3h to the third. This would be 3h squared. Okay, work out. Yeah. Okay, thank you. Okay, so those watching. Quiz 4. So quick. Faster than I was. Yeah. You all set? Got something? Oh, yeah, you do have something. Okay, interesting. Yes. Just bad algebra. That's why. So, okay, let's go ahead and take a look at my answer. Oops. So here's my answer is I start off with this limit. We're going to use this limit today. I told you earlier that today is your day where you don't have to use this limit. And here's the deal is that I'm going to use the limit for you. And then you won't have to use it ever again. Well, not true on the test next week. But anyway, so here's the limit that we're going to use. And I've plugged in this particular function. I did a double negative here, so that's why that's plus instead of minus, because you're subtracting off the original. So anyway, then I have to expand that thing. The 3x plus h quantity squared has to be expanded. So I did my algebra. I know it looks really nasty, but like I said, today I'm going to do the algebra for you so you don't have to. Algebra is usually the reason why people get things wrong in calculus. It's not because you don't know the calculus, it's because algebra is hard. So there's a bunch of algebra we have to do. We're going to cancel some stuff. You probably see this. The 3x squareds cancel. The 2x cancels at the end here. So let's cancel what we can. And then there's some more stuff that we can cancel. Factor out h, cancel that, and you're left with just this. And then once you're all done, should get 6x minus 2. So most of you got 6x minus 2 or something close to it. If it wasn't identical, it's okay. I mean, because like I said, today it's really tedious. This is a lot of work, isn't it? It's a pain. I don't want to have to do this every single time. In fact, I refuse to. I'm going to come up with a list of rules. And so today we're going to go over differentiation rules. And so here's the first thing that I want to point out is that f prime of x is a limit. I know you're sick of this. You're so sick of this. But the reason I point this out is because it is a limit. You can use all of the rules, the limit rules, apply to this. And those limit rules, I guess I could pull up the PowerPoint, but those limit rules are things like this, that if you're doing the limit of a sum of two functions, it's the same as doing the limit of each of the functions and adding them together. If you're doing the limit of a product of two functions, you do the product of the limits. Now that doesn't work quite as well with derivatives, but we're going to use, I guess the constant rule is a good one, that if you have a constant times a function, here, let me just write this down so you might be like, what? Here's what I mean, is that if you know that the limit as x approaches a of f of x is L, and the limit as x approaches a of g of x is, I'll make that L1 and L2, then the limit as x approaches a of f of x plus g of x is equal to L1 plus L2. So you remember this from the limit laws. Like I said, I was just too lazy to find it on my PowerPoint, but here it is. And then here's another rule from the limit laws, or the limit rules, is that the limit as x approaches a of a constant times a function is equal to the constant times the limit. So I think those are the main ones that we're going to use today. So we'll use those two in conjunction with a couple of other tricks to simplify the derivative. Now, here's what I mean by this, is let's say that I have a function like this. Let's use the actual function from up here. 3x squared minus 2x. 3x squared minus 2x. I want to find the derivative of this function. So here's one way to do it, is you could just pump it into the limit formula. The second way to do it is to recognize that what you have here is you have a constant times a function, and that function is x squared. And then you have another constant times a different function, just x. So I could do this. I could say, okay, we're not going to actually formally write these like this, but I could say g of x is equal to x squared, h of x is equal to x, find g prime of x and h prime of x, And then we know that f prime of x will be 3 times g prime of x minus 2 times h prime of x. So in other words, just simplify things, because it would be a lot easier on me to find the derivative of g of x rather than derivative of f of x. F of x is complicated. G of x is simple. So let's actually do this. Let's do this in turn. First of all, I will do g of x. Then I will do h of x. Ooh, too many h's. That's okay. So let's do g prime. G prime of x is the limit as h approaches 0 of x plus h quantity squared minus x squared over h. Okay, that's not too bad. H approaches 0 of x squared plus 2xh plus h squared minus x squared over h. Still not so bad. Limit h approaches 0 of 2xh plus h squared over h. You can see where those cancel. Limit as h approaches 0 of 2x plus h, which is just 2x. Keep that in mind for just a minute. So that's just the derivative of x squared. So going up here, if I happen to know that, and Zach happens to know that, then I would just write this like this, because that's the derivative of x squared. Let's do the derivative of x now, and then I'll show you how this all works. Limit as x approaches 0, or h, sorry, h approaches 0 of, and unfortunately that's h of x plus h, so I chose poorly for my function name, but it's going to be x plus h minus x over h. This one's so simple you could probably do it in your head. Limit as h approaches 0 of h over h, which is just 1. We're coming back to this. Don't worry. That's going to be 1 right there. And check it out. Using this, if I happen to know this, if I've somehow memorized this, which you're going to have it memorized by the end of class, you can easily come up with derivatives like that, just using these rules. Okay, so here's what we're going to do, or what I'm going to do for you, is I'm going to make a little table. And then I have PowerPoint, but this is too exciting. So I'm going to do this, f of x and f prime of x. So if f of x is equal to 1, what is f prime of x? We'll get that in a minute. We've already done x. We did x squared. And we're going to do x cubed, x to the 4th, x to the 5th, and then we're going to say, you know what? I see a pattern. X to the n is going to be whatever it is. Interesting. Sorry. Not really an emergency, I don't think, but Dr. Oliveira cannot open his bike lock. He forgets his, I gave him a bike lock. So he's like, what's that code for the bike lock? There, I've sent him the combination. Okay, anyway, getting back to this. So we're going to come up with a pattern, and then maybe I'll pull up the PowerPoint eventually. I probably should in just a minute. But so this is the sort of pattern that we're going to do, and then we'll use that pattern. So there is a formula. That's what I want to get at. Okay, let's do f of x equals 1. Limit. By the way, at this point, sorry, I keep writing x there. At this point, you might want to just not bother writing all of these limits down because you're sick of them as much as I am. So this is going to be f of x plus h minus f of x over h. A little confusing because this is a constant function, but constant function, f of x plus h is 1, f of x is 1, all over h. hopefully you see that you're going to get 0. So does that look okay? Okay, next we're going to do the same thing for the limit as I'm going to do x cubed. And, h approaches 0. Why did I put a 1 down there? I don't know. So now I'm going to do x plus h cubed minus x cubed over h. So a little bit of a pain, but I'm a professional. I can handle this. X cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed over h. You might start noticing a pattern at this point. So let's see, these x's cancel, and then you can cancel an h. So that one, the derivative is 3x squared. I'm doing 2 more of these, and then you're going to see the pattern, hopefully. You probably see it already. But let's at least do x to the 4th. And I know you're thinking, you know what's coming with x to the 4th. H approaches 0 of x plus h to the 4th minus x to the 4th over h. That's going to be the limit as h approaches 0. Now check this out. As a mathematician, and like I said, I'm a professional, don't try this at home, I can actually do a little bit of, save myself some work. And that is to say that I know that this is going to be x to the 4th plus 4x cubed h plus 6x squared h squared plus a bunch of other stuff. And you might say, well, doesn't that stuff matter? It doesn't matter. And the reason I know it doesn't matter is because everything beyond that in my expansion of x plus h to the 4th is going to be stuff with higher powers of h, higher than h squared. So it'll be h cubed, h to the 4th. That stuff, when I do the limit as h approaches 0, it's going to go away. Like it did up here. I mean, look up here. This stuff, it all went away, didn't it? The h squared, the h, all went away. So as a mathematician, we sometimes do this. We'll say, you know, there's going to be other stuff, all multiples or multiples of h cubed, h to the 4th, whatever. So let's go ahead and cancel, and we're left with limit as h approaches 0 of 4x cubed plus 6x squared h plus a bunch of other stuff that has even higher powers of h. I am only leaving this one here as a sort of example of what's going to happen to all the other stuff. When you plug h equals 0 into this, that goes away. You're left with 4x cubed. So that one's going to be 4x cubed. Let me do one more. This is so exciting for me. In fact, I'm just going to do this. I'm going to cheat and change this to the 5th power. I'll change this stuff here and this stuff. That way I don't have to write as much. But I bet you can guess what this is going to end up being. X to the 5th now. So this will be x to the 5th plus 5x to the 4th h plus 10x to the 3rd h squared plus a bunch of other stuff with bigger powers of h. After canceling the x to the 5ths and also factoring out an h, you end up with 5x to the 4th plus 10x cubed h plus a bunch of other stuff that has a bunch of h's in it. And this limit as h approaches 0 is going to make all of that be 0. And all you're left with is 5x to the 4th. I hope you can see the pattern. Do you see the pattern? I'll bet you do. Here, let's do this. Suppose, let me see. Let me skip this one for now. Let's do a couple more without the limits. So x to the 6th, x to the 7th, and then we'll do x to the n. because it is fun to have a formula. But x to the 7th, see if you can, or 6th, see if you can guess what the derivative is, the function derivative for each of those, x to the 6th and x to the 7th. Jot them down. Let's see if you get them right. I'll bet you will. Let's see what we got here. Let's find a volunteer. Just a sec. Pick me. Randomize. Zach, I know you know how to do x to the 6th. What's the derivative of x to the 6th? 6x to the 5th. Now, if you had to describe this to someone, like, how did you do that? Like, yeah, isn't that interesting how if you take each one of these, the 4 came from up here, and then you subtract 1 from the exponent. So each one of these seems to be that's the pattern, and it is the pattern. You can, if you did this using a limit, you would actually get 6x to the 5th. All right, Ethan, I'll bet you could do x to the 7th. What would be the derivative for x to the 7th? So it's the same trick. You take the exponent, multiply it by x, and then change the power to be 1 less. Very nice. All right, so x to the n, the formula is going to be n times x to the n minus 1. Now, I should caution you that this, at least so far, if we were going to do this really formally, that is, prove every step, then I've basically, well, without actually writing out the work, I've kind of proved this for integers because I'm relying on the Pascal's triangle binomial expansion, and you always end up with that term will be like if you're doing x to the 10th, this will be x to the 10th, 10x to the 9th, and so on. So that's what I'm relying on for this. However, as we're going to see, that formula works no matter what n is. But let's check it. Now, this is the way that our lives are going to be, at least for a little bit, is whenever we come across a function that is new, something that is not the same as what we've been doing, we're going to have to do a limit. I don't feel like doing a limit right now. You know what? Let's do this. Let's see if you can apply this rule to a function. We'll get to limits again, don't worry. But I just want to show you how joyful this is for you. Let's take that function up here. Where is it? This one. 3x cubed, 5x, and 5. Okay, give me a sec. So this is from the homework. I will do this one for you. And then I've got another one for you to do. So from the homework, we have this function. To do the derivative, here's how I do it. Here's what I'm thinking in my head. Just leave the -3 all by itself, leave it alone. And then put some parentheses here. Now I have to think to myself, what is the derivative of x cubed? If I can't remember, I could always just scroll back up here to this and say, oh, x cubed derivative is 3x squared. Excellent. So this becomes 3x squared. So derivative. And then I just write the -5 there, leave it alone. And then I go up here and I say, okay, what's the derivative of x? Derivative of x is 1. So that x there becomes 1. And I realize that you're probably not going to go this far with this one, but I'm going to do it just to show you how this works. So -5 is actually -5 times 1. And the derivative of 1 is 0. And so this will be a 0 there. So notice that I'm using this new rule that I've learned so I can avoid limits and get a derivative without limits. We're not done with limits. Even in 5 minutes, I'm going to have to do another limit. But this gives me a way of computing a derivative without a limit. Look how quick this is. 9x squared minus 5. By the way, anytime you have a constant, the derivative of a constant is 0. So it doesn't matter if it's the constant -5 or the constant 1 million, it's always going to be 0. But anyway, there's the derivative. Look how quick that was. So much easier than doing a limit. Isn't that amazing? So let's try to see how you do with one of these. Let's say that the function is this. See if you can jot down the derivative. I want the derivative of this function. Ooh, you know what we could do? Since it's so easy now, let's do the second derivative as well, which is the derivative of the derivative. So yeah, both of those. That'll be fun. All right, let's see how we're doing with this one. So, Alexandra, were you able to get the first derivative yet? Yeah, what you got? Amazing. See how quick that was? Imagine doing this with a limit. You would be doing x plus h to the 10th power. Whew, I don't even want to think about doing that. That seems like a nightmare. But using this new rule that we have, this new formula, it's so quick. All right, let's do the second derivative. You're not here, but Elena is. What's the second derivative, the derivative of that derivative? Oh, okay. Take a minute. You can do it. Sorry, I pushed a little quicker than I thought. Oh, you got to do the calculator thing? No, it's fine. It's fine. I'll pick another one and then we'll come back to you. Thomas, do you have this one? All right, where'd that 630 come from? Oh, yeah, that's right. So it's 70 times 9x. That's right. And then what did you say, 60? Oh, that's 15 times 4. Okay, so you just multiply by the exponent, and then you get your thing there. And then the 2 goes away, doesn't it? Very nice. Okay, so there it is, second derivative. We could keep going. We don't have to, though, not for this one. Okay, so this feels pretty good to me, that we have a way of finding derivatives. And in fact, we could, if you have, and you will have on your homework, a question that asks you for the slope of a tangent line, you know how to do that. You find the derivative, and then I guess we could do that for fun here. Let's do that, but we do have to deal with we have two more limits to do today. So let's find the slope of the tangent to y equals, let's do 5x to the fourth minus 10 at the point 1, -5. Let's do that one for fun. So find the slope of the tangent line. But you know how to do this. Slope of the tangent line, slope is synonymous with derivative. So you're doing a derivative, and then you're going to plug in that point. So do your derivative first. And then we'll do f prime evaluated at x equals 1. So take a minute, do your derivative. All right, Elena, do you want to do this derivative? Oh no. Okay, here, let's talk me through it. Here's the function.
I started out with doing 5 is multiplied by 4x to the power of 3.
That's perfect. You don't have to simplify it. When I ask you for a derivative, what happens to the 10?
That's multiplied by 0.
Okay, so that'll be like plus 0 or something.
Yeah.
Very nice. Yeah. Yeah, I don't feel like you have to simplify it. I can simplify things. So if I ever ask you for something and you're not done with it, tell me what you got and we'll get it. So hopefully everyone got this. 20, I think it is. 5 times 4 is 20, so that's 20x cubed. Does that look all right? No complaints? All right, now we have to find the slope. You plug in the x value. So remember, this is an x, this is a y value. We want the x value. So we're going to plug in the number 1. And let's see, Sienna, did you plug in 1 to your, did you get, I guess you would have to get the same thing as me first. And then you can plug in the number 1. I know, it's like when, I'll tell you, I have senior math majors. Like I'll have a senior in my office, we're working together, and I'll say, yeah, to do this, you just do 2 plus 3, and that's your answer. And they'll pull their calculator out to do 2 plus 3. So what did you get?
20.
Yeah, 20, of course, because it's 20 times 1, right? So so don't feel bad. I remember years ago, this is before the automation at the cafeteria. I showed up at the cafeteria with my wife, and the kid had to like figure out what $3.50 times 2 was. And he was shaking. He pulled out he's like, "You're a math professor. I better get it right." It's really funny. So don't be nervous or whatever. Don't feel bad if you want to use your calculator. But anyway, or maybe just feel a little bad, but not too bad. So there it is. That's the slope. That is the slope. By the way, when you see derivative, especially in the context of a curve like this, you might see y prime written instead of f prime. It's the same thing. Y with a little prime, a little like a quote, single quote next to it, it means it's the derivative. Okay, there's 2 more limits that I need to do. I guess we maybe not get to the PowerPoint at all, which is fine because we will have everything done. I got too excited writing it all out. So here's one of them that we need to do. And some of you may already know what the answer is going to be. And then the other one we need to do is going to be the square root of x. Maybe we'll do the square root of x cubed, just to make it a little bit more interesting. Okay, so let's do this one first. So I want to do the derivative. So once again, at this point in your mathematical careers, most of you are not going to care about the limit, and that's fine. So you don't have to copy all this stuff down. All you're going to care about is, in fact, here's what I'll do. Let's erase this. I will change the color of my pen to green. When it goes back to red, that's when you care. So let's do this. So this is going to be 1 over x plus h quantity squared minus 1 over x squared over h. You've done things like this, haven't you? I made you suffer with things like this. Well, we're going to learn a shortcut, just like you knew it was coming after this shortcut up here. It's like, well, there must be a shortcut here. Yes, there is, and it will come in red in just a minute. Oh, let's move over instead of down. Okay, so this is going to be the limit as h approaches 0. I'm going to multiply both the top and bottom of this by x plus h quantity squared and x squared. So x plus h quantity squared times x squared. That'll clear out all those denominators. And you're going to be left with, let's see, on the top, this will be x squared minus x plus h quantity squared. On the bottom, I'll have h times x plus h squared times x squared. Okay, so there's some fancy algebra there. I know I just combined like 3 steps into 1, but I'm doing it in green, and so you probably don't care. You only care about what we get at the end. Trust me on this. Yeah, by the way, I do this because I'm a mathematician and I feel obligated this is what mathematicians do. So if you're in engineering or any like the sciences, this is what the math people do so you don't have to. Math people love doing this. So yeah, just appreciate what I'm doing for you here, I hope. So this is going to be x squared minus 2xh minus h squared all over hx plus h squared, x squared, sorry. Limit as h approaches 0. I'm almost done. Cancel those x's, and you're going to cancel the h's so that you're left with limit as h approaches 0 of negative 2x. Sorry, I said I was going to cancel the h's as well, combining two things in one here. I'll explain. So if you are trying to track this, the x squareds cancel, then you can factor an h out of what's left, and that h cancels with the h on the bottom. And then now there's no problem with just plugging in h equals 0, and I get negative 2x over x. Oh, sorry, that square is in the wrong place, isn't it? Well, I fixed it now. X squared, because it's x plus 0 squared, times x squared. And that ends up being, we're back to red, negative 2 over x cubed. So, I know, it's like, what in the world? All of that work in green was for nothing. No, it wasn't. That was to help me to fulfill my obligation as a mathematician. Okay, so let's get to what this is all about. When I'll summarize here, here's what you care about. If f of x is 1 over x squared, then f prime of x is equal to negative 2 over x cubed. Weird. In this case, the exponent gets bigger instead of smaller. Remember up on that chart that we made, the exponent kept getting smaller. Here, let me show you what I mean. So when f of x was x to the 7th, you got 7x to the 6th as your answer. Well, it turns out that this rule, is the same rule that we're going to apply down here. It's just been masked. It looks different, but you're going to use the rules of exponents to rewrite that as a negative exponent. Now let's use that rule that we had. Let me copy that rule so that you don't think that I'm making things up here. Give me a sec. I'm going to copy this stuff right here. Copy, paste it down here. Paste, there it is. So on the left, you have the function. On the right, you have the derivative. Notice that if you have x to the negative 2, then n equals negative 2. And so I could write this as using this negative 2 x to the negative 2 minus 1, which is negative 3. And check it out, it matches. It matches up. And so this means that even if you have something like this, I know this is, now I'm really flying, but let's say you have something like this. F of x is equal to, let's make it hard, 5 over x cubed minus 7 over x to the 10th. So something like this. You can still apply this rule, this power rule, just rewrite your expression so that you have no fractions. So negative exponents are fine, just no fractions. So x to the 10th in the denominator means x to the negative 10th, and then apply the rule that we learned already. F prime is 5 times negative 3x to the negative 4. Be super careful with the negative exponents. Negative 3 minus 1 is negative 4. And then you get negative 7 times negative 10x to the negative 11th. You're going to make a mistake. I guarantee it. Everyone does. You're going to accidentally put negative 9 here, for example. It's tempting because you're going to get used to subtracting 1 from the exponent, and you see this 10 here, and you're going to think 9. It's okay. Just, you can recover from that. So remember, negative 10 minus 1, negative 11. So this power rule is going to work for those sorts of problems. One more type of problem, and then we'll wrap it up with a monster problem that is going to give you a lot of joy, or maybe, well, it'll give you a lot of joy, I think. Okay, so we've got this. Any questions about this? Negative exponents? I don't have any practice for you. If I was following the PowerPoint, I'm sure I would. But I have in mind, I need this one more thing, and then we need to wrap it all up. So let's do the one more thing. One more thing is f of x is equal to x to the 3/2. Let's go with that. Just x to the 3/2. Because you remember I mentioned that my power rule, the rule that we had at the beginning, it only works for integer exponents. So what do we do with this? Well, we're going to do the limit. Limit as x approaches, change colors here, right? Because you don't care about the limit. Just a sec. F prime of x equals, you care about that, but you don't care about this. Limit as x approaches, h approaches 0 to the 3/2 minus x to the 3/2 all over h. What a nightmare. But like I said, I'm a professional. I will deal with this. And then you can just enjoy the fact that you don't have to deal with it anymore. So h approaches 0. This thing is actually the square root of x plus h cubed minus the square root of x cubed. We've dealt with things like this before. What I'm going to do is I'm going to multiply by the conjugate of that thing in the numerator, cubed minus plus x cubed, x plus h cubed plus x cubed. And then if you'll forgive me for not showing you all of the steps, you'll just have to trust me that I know what I'm doing. I'm a professional. I can do this. You end up with x plus h cubed minus x cubed over h times this nasty thing. There. So after all is said and done, simplifying, that's what that gets to. I'm going to blow through this so quickly, it's going to make your head spin. So h approaches 0, x cubed plus 3xh squared h plus 3xh squared plus h cubed minus x cubed. Those cancel. H times this mess. And then you can see here what's going to happen is I'm going to cancel that. That's going to be a 2 there and that. Now I can plug in h equals 0, and I get 3x squared. That thing, that means we got 5 minutes, don't worry. And that thing will both be 0. That's a 0 there because we're doing the limit. So I guess I have 2 of these. X cubed there. And now if I just clean up my stuff here and use the rules of exponents, x cubed to the square root of x cubed is the same as x to the 3/2. Oh, that should be red or blue or some other color. Yeah, this is what you care about down here. Give me a sec here. I'll change the color to blue. And that's it. So let me just summarize, I guess, all of this. What this means is that you don't have to do a limit, at least for exponents like this ever again, because check this out. If we were to just use the limit rule with f of x equals, or not the limit rule, the power rule for this, what you're going to get is multiply by the power. So let me just show you this. So you take that, you do 3/2 times x to the 3/2 minus 1, which is 3/2 x to the 1/2, which is exactly the same thing as what I did. All of that work is not necessary anymore. Isn't that great? Okay, so here's the sort of thing that you're going to see on your homework, because once you know these rules, it's so easy to do a derivative. So because of that, Lumen is going to make you do stuff like this. So let me just show you really quick. We have something like this. There. So you're going to have something like that, and you're supposed to come up with the derivative. Now, there will be some normal derivatives that you do, but you'll have something like this. If you have one of these, here's the trick. First of all, break this up into 3 fractions. Second, we're going to simplify each of the 3 fractions individually. Now, if you're not as quick as I am with that x to the negative 3 halves, let me just point out that this is the same as x to the 1/2 divided by x to the second. And the rule is when you divide exponential expressions, you subtract the exponents. So it's 1/2 minus 2, which is negative 3 halves. And now we can do the derivative. F prime, that's going to be 1. You can just go back to the table and find it. This one, a little bit harder, negative 3 halves, x to the negative 3 halves minus 1. I'll have to do a little bit more work there. And then this one is going to be 7 times negative 2, x to the negative 2 minus 1, which will be negative 3. Give me a sec. This will be negative 5 halves. And that'll be negative 3. So it's going to be a little bit challenging, but I hope you can at least appreciate that for Monday at least, you don't have to do a limit. There are no limits involved. So, yeah, I thought you know what? Yeah, I completely ignored my PowerPoint. Just a minute. Let's just take a peek here. I think in the PowerPoint I had something about next week. Let's take a peek at next week just to make sure that it makes sense. Next week. So what you can expect next week is the practice on the differentiation rules is Monday. Tuesday, we'll have some more differentiation rules. Wednesday, even more differentiation rules. And then Friday is the exam. I will have a practice exam online for you by Monday so you can look at it. But so notice what we have here. I'll even do this one for you. F of x equals 16, the derivative is 0. It doesn't matter that we're looking for the derivative at 8, still at 0. X to the 20th, you know the rule now. I'm not going to do that one for you. Look at this. These are so easy now. You can do them in your head, can't you? The answer there is 18. This one, yeah, I could do this one in my head as well. Super quick. Okay, so here, this one. To do that one, you're going to have to do a little bit of algebra first. It's sort of like this one that I showed you with the fraction. Just do FOIL with that, and then do the derivative of each term. This next one, it's asking for, I don't know, well, once again, it's looking for derivatives of basic nuggets of, those are easy. Here's one. That one is harder. That one's easy. Oh, they're all easy except for there's 2 of them. So number 8 and number 5, I think, are the ones that you're going to have the most trouble with, but the rest should be pretty quick. Remember these rules, and I think you'll be in good shape for Monday. But do feel free to message me if you need to. I'm going to pause the recording or stop it so that if you do have questions,